Okay, it is Wednesday the 21st, and we are multiplying by a monomial. So what's a monomial, you say? Well, it's a term that just has one spot. Oops, that one's out of ink. Why don't we throw that away so I don't do that again? Good plan. All right, so that's one term. Another example, as long as there are two things that are multiplied together like that, that's a monomial. Even this is a monomial. You can have several things all multiplied together, but that's a monomial. That's what a monomial looks like. And what we're going to be doing is we're going to be multiplying times that. So the rules are you have to multiply the numbers. Multiply would be nice. Multiply the numbers. And you have to add the exponents. So that is what we are going to be doing. So the first example looks like this. Here we have x to the third plus 4. All right. Now then, if I multiply like I'm supposed to, I distribute. Remember the distributive property. Take this whole thing and multiply times this. So I have to remember that I'm multiplying the numbers involved. Well, there's a 3 there. And remember, there's a number here. It's 1. So I'm multiplying the numbers. That's 3. And I'm adding the exponents, so that is 3, 4, 5, x to the 5th. Right? So I multiplied the numbers and I added the exponents. So now I look over here and I say, well, I've got numbers, 3 times 4. Well, I know that's 12. What about the exponents? I'm supposed to be adding the exponents. And notice that there's not a letter here. Well, when there's not a letter, that means it's x to the 0. So if there's nothing there, that means the exponent is 0. So if I'm adding exponents, I do 3 times 4, that's 12, and then I do 2 plus 0 is still 2. Right? This is the answer after I multiply by the monomial out in front. Let's do it again. Let's do it with this guy. This will be a to the third plus 5ab squared plus, I'm getting close to that center part. Let's try b to the third. In fact, we'll do 2b to the third. There we go. Just for fun. Okay. Now remember, we're supposed to multiply the numbers. Well, what's the number? Well, there's a number 1, and there's a number 1 there. There's a number 5 there, and number 2 there. So now we know all the numbers. So when I multiply 1 times 1, I still get 1. And then I have to add the exponents. Now, if there's letters, see here, when there's no letter, that means it's x to the 0. If there's letters there and they don't have an exponent on it, it's automatically 1. So these guys are 1. This guy right here is a 1. All right, so we have to say I'm adding the exponent here to the 3, but I can't add the exponent on b to the exponent that's on a. So I'm going to have 1, a4, b1. So what happened? I added the 3 to the 1 on the a, and then this b, there was no b to add to. Right? So there you go. Now I multiply the numbers. 1 times 5. Well, that's just 5. And then now I'm adding the letter here. This is a 1, and if there's nothing showing, see, that's a 1. So that makes a2. And then b1 and b2, that makes b3. See, I can add exponents when they're on the same letter. When they're not on the same letter, it just stays like it is. So here, if I go this way, I'm going to have 2, because 1 times 2 is 2. A times, there's not an a in there, so the a stays the same. And then b, that makes b to the fourth, right? 3 plus 1, that's 4. Yay! All I'm doing is multiplying the numbers and adding the exponents. So let's try it one more time. One more time. This will have numbers and letters in it, so we can make sure and get everything wonderful. So we'll have 4c squared d, and then 6. We'll do cd, and then 8. We'll have cd squared. There we go. Now then, what do you think? When I multiply the numbers, that's going to be 12. And when I add the letters, remember I can only add the letters on the C to the C and the letters on the D to the D. Okay? So, if you don't see anything there, that's a 1, 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 right? So it might be good for you to put those 1s back where they go. That's true. So now, 3 times 4 is 12. No problem. I add the letters, so that makes C to the third. I add this one, that's 2 plus 1, that makes D to the third. So that one's done. And then 3 times 6, that's 18. Woo woo! I add the letters, this is 1. That's 1, so that makes 2. This one's 2, and that's 1, so that makes 4. Where'd I get 4? Ha! 2 plus 1 is 3. There you go. Yeah, it's 4 only on Tuesdays, but today's Wednesday, right? Ha! Right, 3 times 8, that's 24. Woo woo! Add 1 plus 1 again is 2. And now 2, that's 4. So, lo and behold, we have the answer right there. So, I multiplied the numbers and I added the letters. Right? So just be careful. Now then, you cannot, some people want to add these all together. I should have talked about that. You can't add these up here. You know, 3 plus 12, well, that's 15. No, because these letters are different. You can't add them if the exponents are different. The letters are the same, but the exponents are different. So you cannot say 15, what is that, x7. That would be wrong, wrong, wrong. You can't combine them if the exponents are different. So these, that's the answer. Here's the answer. All of these exponents are different. I cannot add anything together. Right? Here the exponents are all different. You know, well, you say, well, there's a C2 and a C2. Yeah, but the D3 and the D4 are different. So you cannot add them unless they're exactly the same. If this was a C2, D3, and this one was also C2, D3, then you could add them. But you can't add them unless they're exactly the same. All right, that's the answer. You should be able to do today's homework in the book on page 162. That's it. Bye-bye.